Kids. All right. Hey, I'm going to do a vertical displacement problem. We're taking a ball, you're throwing it straight up off a 10-meter high bridge. Sorry, it's a little glary, but whatever. With a speed of 15 meters per second. Can you actually throw that? Yeah, because even I could throw something 30 miles an hour. We want to know how high does it go, what's the time in the air, what's the speed it hits the ground, and whatever else I could ask you. But that's just some example questions. So we're going to solve this, and first thing we want to do is we want to sketch a quick picture of what's going on. So here is my bridge or wherever. We're going to throw it up, and then it's going to come back down like this. I'm going to label some points. I'm going to say, hey, this is A, this is B, this is some random point down here, D. Why D? Because most of the time we'll label this returning height point, point C. So just some random points. You can label it whatever you want, but there you go. So then after you draw your picture, you need to figure out, okay, if I want to figure out how high does it go, where am I going from on my picture? Oh, I'm going from A to B. So I'm going from A to B, and actually let me label this as well, just so I have it. That's going to be 10 meters. So if I'm going from A to B, what do I know? Oh, I'm going from A to B. I know that my final velocity is 0. Here's where you guys got to be careful. The initial velocity is right after it leaves your hand. Right after it leaves your hand, it is going 15. So my initial velocity is plus 15 meters per second. This would be different than if he was throwing it straight down. Then you would have to plug in a negative 15 meters per second because, hey, you know what? Direction's important. If you write down your acceleration, well, we're going to assume on Earth, so the acceleration due to gravity is going to be negative 9.8 meters per second squared. And then A to B, this 10 doesn't come into effect. So what am I trying to find? I'm trying to find my displacement. Okay. And if you have this, then you would say, all right, I'm going to plug my stuff in. I know I'm going to be using this formula, so I'm going to write down my formula. In this case, y or x, and then slam your numbers in. So 0 squared equals 15 squared plus 2 times negative 9.8 times y, and then plug it in and solve for y. So 15 squared divided by 19.6, and you get y to be positive 11.5 meters. That's important because, hey, going from A to B, I went up. So I went 11.5 meters up. So how high off the ground it is would be 21.5 meters. How high is it from his starting point? It would be 11.5 meters. Hopefully that's good and it makes sense. All right, so then if we want to figure out the time in the air, so if I'm going to be doing that, I need to write down some different givens. So now I am going from, okay, so again, I'm going to use my picture. Hey, I'm going from A to D, because that's the time that it is in the air. So if you're going to write down what we know, okay, well, I'll start with this because that's the easy one, because I'm still on Earth and still accelerating due to gravity. Here's where you guys got to be careful, okay? This is not 0. Why is it not 0? Because where along the path is it 0? It's 0 at the peak. Remember, point D is right before it hits the ground. So that is not true. Don't make that mistake. Make it somebody else make that mistake. Don't be that kid. Y is going to be 10, but here's where, again, you got to be careful. I'm going from here to here. I'm finishing underneath my starting point, so make sure you plug in negative 10. And then my initial velocity, VO, is plus 15 meters per second. And I am looking for my time. Okay, is everybody with me there okay? All right, so if I was going to try to plug this in, I could use this formula. Okay, here's the issue though. If you use this formula, you're going to have to solve a quadratic. And I don't love the quadratic. Why? Because I'm not a math teacher. So if you don't love the quadratic, then let's not use this formula. Let's do something else first. Let's use this formula. Let's use this formula first, and we're going to solve for the final velocity at point D. So if I plug that in, I get VF squared equals 15 squared plus 2 times negative 9.8 times negative 10, and plug it in, so 15 squared plus 2 times 9.8 times, hang on, this is supposed to be a plus, times 10, and I got to take the square root, and I get 20.5. So here now is where you got to be careful. Okay. Here's what my calculator says. Here's what my calculator says. See? That's what the calculator says. So here's where you have to be smarter than the calculator. Okay? The calculator doesn't know when you take the square root, well, that you need to do plus or minus. You do. Why? Because you're smart. The calculator's not smart. You need to do plus or minus. Then you need to think, oh, wait, I'm at point D. I want the minus 1. Why do I want the minus 1? Because I'm going down. Okay? So hopefully that makes sense. I'm going down. Now if I take and I plug it into an equation to solve for my time, I can do that. And I know everything, so I'll just pick my favorite equation. And if I pick an equation to snuggle up with at night, this is the one. So I'm going to use this one, plug it in, negative 20.5 equals plus 15 plus negative 9.8 times t, and I can solve for that for t. So times negative 1 minus 15 divided by negative 9.8, and I get my time to be 3.62 seconds. Now sometimes, guys, we do problems where it's like, hey, you have to double this time. Again, look at your picture. Where are you going from? I'm going from here to there. Oh, that's just the time. That's the time. And then I found, actually this part 2, the speed that it hits the ground is not negative 20.5 meters per second. It would be 20.5 meters per second. Why? Because speed does not have direction. All right. Bye, kids.